We would like to introduce you to what is a design integral advanced approach towards. It includes methodology and advanced techniques, and it also involves geometry as the main tool towards during the whole design process. Later on, I would like to introduce you to the notion of genotype and how it becomes our mother model and a conceptual model towards the final architectural product. As I said, we are pretty much interested in geometry, as we borrow concepts from another disciplines. We bring them to architecture. In this case, we are interested in the nodes. The nodes have the characteristic of combining different directionalities. We are pretty much interested in the crossing of this directionality. This point of exchange actually gives us information, and a node as a development of this point is a minimal unit of an extended open organization. It determines directionality, condenses information. It can connect or separate different programmatic areas. It can act as a distribution or performance and attractor. An evolution of what we consider the node is a genotype. We would like to introduce you here this genotype as a generic model. It's a tool for the design. It has the capacity to evolve from the node into a reaction. This reaction, it goes within a specific scenario and a certain input. And the more specific this input will be, the more specific the problematic is set up within this scenario, the more variations we have on the same genotype or conceptual model. So here we will introduce you three examples of this genotype. One is the tree or branching structure, the second one is the bundle, and the next one is a network. The bundle is a structure that is composed out of linear elements. It is one directional. Elements can get together towards a point, converge into one point and produce this exchange of information, or can get just close together and have the potential of a certain exchange. I think over the part to explain in 3 case studies how we translate this geometrical model into an architectural model. This is actually what gives the architectures later the identity also. This is an extension of the summer house in Patagonia, and the space is actually entirely articulated through a tree structure. This is what Cynthia was referring already before. And the tree structure takes over this supporting role, and it's instead of a column grid. This project is generated by a computerized algorithm. This is what we call a script. And this script simulates the bifurcation process of natural growth. And this gives endless variations of possible solutions. If you work with a script like this, it's important to define the input very clearly and afterwards to evaluate the outcome according to structural, architectural, and also material considerations. Some of the limitations that were put is, for example, a new roof shape that cuts off the branching, and this will become the structural members for the new roof. Then, by setting obstacles like existing structure, like for example the chimney that was existing, redirect the branching of the tree. The tree has of course a very big spatial impact. The whole movements and the circulation of the space will center around this wood structure. And the branching is creating a structure as well as a visual gradient from the bottom until up to the roof that resembles to the context. It's giving the feeling like sitting under a tree or being protected by a tree. Another essential point in this project is how to bring it back. This is a computer-generated model to bring it back to in a way that this can be produced and manufactured by local standards. So instead of making a customized knot, what is normal consequence of the digital production method, this is done in a way that it consists of bended steel tubes that are arranged in a way that they follow the structural forces. The next project, what I want to show, it's actually something that you cannot see. It was a structure, it was an installation for a museum for blind people, and it's actually for blind people, but it should give the impression to visitors what kind of perception have blind people. So it should deal with all the senses except their sight. The installation space was completely filled with linear elements that were free floating from the ceiling. And this was inactive matter. And in the moment the visitor is entering the space, this inactive matter gets activated, and through the movement of the visitors, it's endless variations of effects created. The elements are from the same dimension, but they have different material and different sections. So this creates also a different tactile and audible experience. And the effect what actually was created is that the visitor is moving through the space and gets a feeling of what is space through although it's no material there. The last thing what we want to state is actually that you can facilitate interaction through a geometrical structure. This was a work done by an interdisciplinary group of artists and architects, and was for their final exhibition. It's an exhibition space, and the structure is separating it in two parts. The upper part is serving as a form of a theater, and the lower part is more this the traditional exhibition space with individual spots for exhibiting the artwork. So in this case, the structure is dividing the space programmatically, but at the same time, it's also connecting it again and letting it show as a whole. The two spaces are connected through holes that are called social spaces that allows people to gather around the art piece on two different levels. And I think it worked pretty well at the end, because during the time of the installation there were a lot of performances, talks and discussion rounds, and it was in a quite stimulating atmosphere, and the whole thing was underlined by interactive media installation.